There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
Right now, a visitor from another star system is making its way through our cosmic neighborhood, and what scientists discovered in the past few weeks completely changed what we thought we knew.
You've been telling me for months now that you think this might be an alien object. Is this a disappointment?
The tail that vanished has mysteriously returned, longer and brighter than before. Something unexpected is happening with 3I Atlas, and the real story is just beginning to unfold. The comet returns from hiding. After weeks of being invisible to ground-based telescopes, 3I Atlas emerged from behind the Sun in early November 2025, and astronomers immediately noticed something dramatic. The interstellar comet passed its closest point to the Sun on October 29th, reaching perihelion at a distance of 210 million kilometers. During October, the comet was hidden from Earth's view because it sat directly behind the Sun from our perspective, making observations impossible with traditional telescopes. However, spacecraft orbiting Mars kept watching it during this blind period, maintaining continuous observations from their unique vantage point 30 million kilometers away from the comet on October 3rd. When the comet re-emerged into the morning sky in early November, astronomers rushed to capture new images, and what they saw left them stunned. The mysterious tail transformation. The ion tail of 3I Atlas has grown spectacularly longer and more structured since the comet's reappearance, displaying features that scientists did not anticipate. Images captured on November 10th revealed the tail now stretches nearly 0.7 degrees across the sky, visible despite challenging observation conditions, with the comet sitting just 14 degrees above the eastern horizon and a bright moon interfering with visibility. The tail consists of charged particles stripped from gases sublimating off the comet's nucleus by solar ultraviolet radiation, then pushed away by the solar wind into a long, straight stream pointing away from the Sun. What makes this particularly intriguing is that the tail had essentially disappeared from view during the comet's approach to perihelion, only to resurface dramatically more prominent than before. The sudden resurgence marks a significant turn in understanding this interstellar visitor's behavior, showing that comets from other star systems can be just as unpredictable as those native to our solar system. A visitor from the ancient past. The origin story of 3I Atlas reads like science fiction, but every detail comes from rigorous scientific analysis of its trajectory and velocity. Computer simulations tracking the comet's path backward through space suggest it likely originated from the thick disk of the Milky Way, a distinct population of older stars located above and below the main galactic disk where our Sun resides. This thick disk contains some of the oldest stars in our galaxy, leading researchers to propose that 3I Atlas could potentially be 11 billion years old, making it possibly the oldest known comet ever observed. The comet's hyperbolic orbital path confirms it is not gravitationally bound to our Sun, meaning it will pass completely through the solar system before continuing its journey across interstellar space. The specific star system from which 3I Atlas was ejected remains unknown, lost in the deep history of our galaxy's evolution. Its high velocity through space provides the key evidence pointing toward the ancient thick disk origin, distinguishing it from younger comets born in more recent star-forming regions.
Before we go on, like this video, smash the subscribe button and click the notification bell right now.
The carbon dioxide mystery. One of the most puzzling discoveries about 3I Atlas involves its unusual chemical composition, particularly the shocking ratio of carbon dioxide to water in its coma. Observations from the James Webb Space Telescope revealed that the comet's gas emissions contain approximately 8 parts carbon dioxide for every 1 part water, one of the highest ratios ever measured in any comet. Most comets in our solar system show the opposite pattern, with water dominating their volatile emissions. This extreme carbon dioxide abundance suggests 3I Atlas may have formed near a carbon dioxide ice line in its original star system, or perhaps in an environment with unusual radiation conditions that differ significantly from the region where our solar system formed. The comet contains only 4% water by mass, far lower than the primary water content familiar in typical comets. Despite this oddity, the comet is actively outgassing all the normal substances expected from comets, including water, carbon dioxide, and carbon monoxide, just in ratios that fall outside the usual range. This composition tells scientists that interstellar objects may share more similarities with solar system comets than previously thought, while also carrying the unique chemical signatures of their alien birthplaces. The nucleus beneath the glow. Determining the actual size of the solid nucleus hiding within 3I Atlas's glowing coma presented a significant challenge that required the sharpest images available from space. The Hubble Space Telescope captured detailed images on July 21, 2025, revealing the coma structure in unprecedented clarity and constraining the nucleus diameter to below 5.6 kilometers. Further analysis, combining multiple observation techniques, narrowed the estimate to between 0.32 and 5.6 kilometers in diameter, with predictions suggesting the nucleus measures approximately 1.2 kilometers across. This small nucleus is surrounded by a much larger cloud of dust particles ejected from the surface as volatile ices sublimate under solar heating. In July 2025, observations indicated the comet was ejecting 6 kilograms of small dust particles per second and 60 kilograms of large dust particles per second from this compact nucleus. The dust grains show a wide size distribution, with tiny particles measuring 1 micrometer in radius shooting away at speeds of 22 meters per second, while larger grains measuring 100 micrometers move more slowly at about 2 meters per second. These measurements help scientists understand how much material the comet is losing during its passage through the inner solar system and how long it can sustain this level of activity. Early activity surprises. The comet began showing signs of activity far earlier than anticipated, revealing its volatile nature long before it entered the inner solar system. Observations from the Transiting Exoplanet Survey satellite captured images of 3I Atlas between May 7th and June 3rd, 2025, before the comet was even officially discovered, and these early images showed the comet was already bright and active. At that time, the comet sat roughly 6.4 astronomical units away from the Sun, far beyond the typical distance where water ice begins to sublimate. This early activity indicates that volatiles other than water, such as carbon monoxide and carbon dioxide, were already sublimating and driving the comet's outgassing at great distances from the Sun. The activity level appeared steady through August 2025, with no detected outbursts or sudden brightness changes, suggesting a consistent sublimation rate rather than explosive events. A spin period of 16.16 hours was measured through photometric observations conducted between July 2nd and July 29, 2025, showing the nucleus rotates relatively slowly as it tumbles through space dust mass. Loss rates varied from 0.3 to 4.2 kilograms per second during this early observation period, indicating the activity level fluctuated but remained within a consistent range. Organic riches from another star. Spectroscopic analysis revealed that 3I Atlas carries complex organic materials that hint at the chemical processes occurring around its parent star billions of years ago. Observations using the Southern African Large Telescope and the Nordic Optical Telescope showed the comet's reflectance spectrum exhibits slight reddening in the optical range from 400 to 700 nanometers, with a spectral slope of 22.8% per micrometer. This reddening signature suggests the presence of organic-rich materials similar to those found in comets, originating from the outer regions of our solar system. Near-infrared spectroscopy revealed a complex, curved spectrum that points toward a mixture of different grain sizes and compositions in the coma. The absence of clear water ice features in the spectrum, combined with the observed curvature and broadband color measurements, hints that the surface or coma is dominated by complex organic compounds, refractory dust particles, or specific grain size effects that mask volatile signatures. The complex grain mixture influences how light scatters off the comet, contributing to the spectral curvature and the transition from reddish to neutral or bluish slopes at longer wavelengths. The nickel anomaly. Among the various gases streaming from the comet's nucleus, scientists detected an unusual abundance of nickel that sparked intense discussions about what it might mean. The gas plume contains much more nickel than iron, and the nickel-to-cyanide ratio measures orders of magnitude larger than observed in any other known comet, including the previous interstellar visitor. 2I Borisov's statistical analysis suggested this combination has a likelihood below 1% when compared to the population of known comets. While this represents a genuine anomaly in the sense of being an extreme value, it remains consistent with what scientists know about comet composition. What comes next? The comet's journey through our solar system continues with several important milestones approaching in the coming months. On December 19, 2025, 3I Atlas will reach its closest approach to Earth, passing within approximately 270 million kilometers of our planet. This distance poses no threat whatsoever, but provides an excellent opportunity for detailed ground-based observations with large telescopes under ideal viewing geometry.